Hello, this is Jose Luis here at Parametric Camp, and welcome to this demo video where I just kind of want to show you something that I made for fun the other day and that I'm actually really happy, I'm really nerdy proud of, and I wanted to share it with the world. This is not going to be a tutorial video because there's many things that went into doing what I just did, so maybe I may record tutorial videos in the future, but I just want to show you that I am a big Minecraft fan. I play a lot of Minecraft, and I had some free time last weekend, so I was like, I had always wanted to get my hands dirty into figuring out the file format that Minecraft uses to store the regions and the worlds. And I wrote this thing that deserializes Minecraft regions and then gives you a CSV file basically of all the voxels in a particular region in a chunk. And then I wrote this other thing that then takes those CSV files and visualizes them as a voxel field in a 3D modeling environment that I use a lot, which is Rhino and Grasshopper. So what you can see here is a 3D model that I have of three chunks of the Minecraft world that I've been playing in lately. And you can see that there's a cave here, there's a couple of water caves, there's some what is it called, redstone here. I believe this is lapis, and this is like a chunk that is close to the border with a big river. So you can see the river, some sand, some water in the cave, etc. And actually, because of the 3D modeling environment that I'm using, you can also create a section. You can create a clipping plane that travels through the chunk and then gives you a visualization of what is actually inside the chunk. And if you animate this, you can make a video such as this one where you can like slice through back and forth the whole chunk and make a visualization out of this, which I think is very, very cool. So what I want to show you is kind of the basic steps that I followed to do this. I'm not going to get into the house. That would take some time. But I just want to do this for fun. So let me show you how I started and then how I did this. So first of all, what I would like to say is that I'm a huge fan of Minecraft, and I'm also very nerdy and I like coding. So I've always kind of wanted to find a way to like make those two worlds collide. And I've always been a fan of projects such as, for example, those projects that are apps or a mod that somehow take a look at the world that you're playing at a particular moment. And for example, I'm a huge fan of this project called Unmined, which is a Windows application that allows you to load your Minecraft worlds. I actually have it somewhere here. I actually have it right here. Okay, so yes, so I'm going to load this world right now, and you can see it just renders the world at a super, super high definition per pixel. This project is amazing and it's so fast. And then I can just cut a section through some part of the world. You know, I'm going to start cutting down, and then you can see that you can start seeing the caves and you can start seeing the mine shaft. This project is amazing, and you can render out a high quality PNG. I'm just amazed by this project. So I was very inspired by this project, and I was also very inspired by this other one. It's a web application. It's running on Deck.gl, which is kind of 3JS, but it's more geared towards visualization. And it's basically a chunk viewer as well. So you can drag your Minecraft files, and then you will see it in 3D. You can choose which blocks do you want to see, right? I want to see these chunks here. And then it's amazingly fast especially on a browser, which is kind of amazing. You can see here, and then you can also make like horizontal cuts, and I think you can also make vertical cuts. I'm not sure how that works, but you can see the caves, and you can like try. You see, we found diamonds here, you know. So this is pretty cool. The only problem is that I believe this project has not been updated in 2 or 3 years. So when I actually tried my 1.18 worlds on this project, it didn't work. I couldn't load my worlds. So I actually started by thinking, well, can I just try to fix this project and make a fork that works with an updated version? But then I had actually no experience whatsoever with the file format itself. So I thought that perhaps starting from scratch and like taking a look at the file format would be a better approach. And that's kind of what I did. So I spent some time reading through what's called the Minecraft region format. Because if you're familiar with Minecraft, you know that you can go to your Minecraft folder, whatever that is. You can go to saves, and in saves you have the worlds that you're playing with. So these are actually dumps from my Minecraft realms. They're not they're not actual worlds that I play in. But if you go in and if you go to region, what you can see is that you have a bunch of files that are called MCA files, and they have this kind of cryptic naming R and a few numbers. So each one of these files is called a region file, and these files contain basically the information of each tiny voxel or each tiny Minecraft block, but the information is contained in very, very specific file format for the purpose of optimizing how to save this information in as little room and as little bytes as possible. Because it turns out that voxel spaces, so basically regions that have voxel information in 3D, are actually pretty heavy computationally and information wise. So finding optimal ways of storing that is kind of a challenge. And actually Minecraft has a really good approach to that. So I'm not going to get into the details, but it turns out that the file format has a specific header about that specifies where the chunks are stored, and it has a particular way of flagging how much they weight in the file system and the type of compression that they use. Again, I'm not going to get into the details of this. Maybe I'll make some video in the future. And then at some point in 1.7 version, they changed the file format. I'm totally probably not 1.7. At some point, they changed the file format, and they turned into this thing called the Anvil file format that has a few changes to it. And all of this is also based on this particular data structure that they use for storing information that is called the NBT file format, the named binary tag, which is a tree structure. So it's basically like a JSON file, but it's much more optimized because it's typed. It's not like key value pairs of strings and some other. It's a bit more it's a bit more optimized. So after some reading from the Minecraft fandom website, but also this other website that I found that was extremely useful because it had a bit more technical information about things, and specifically the chunk format was very well explained on this website. This was extremely helpful. So is reading this, I was, and also using some open source libraries, such as, for example, FNBT, this library, this C# library for deserializing the NBT format, and also using some online editors for reading NBT files, I was actually able to put together a really rough prototype to be able to read these region formats files and generate CSV files with the coordinates of each block for the region and what kind of block that block is. So let me actually show you what that looks like. What I did was I started this console application that I'm calling the Minecraft Anvil parser that looks something like this. So it has a main program, right? This is the entry point for the console application. And what I did was I wrote a bunch of abstractions for the entities that compose a Minecraft region. So I'm not going to get into that, but basically Minecraft is divided, the whole Minecraft world is divided in regions. Each region is divided in chunks. Each chunk is divided in sections, and then each section is made up of blocks. So each block is that one individual voxel that can be diamond, dirt, rock, whatever that is, right? And also a bunch of utility functions that I made for myself to stringify things and to spit things out as a CSV file. So once I did that, which again, I will get into the details perhaps in another video. Once I did that, then creating a simple program that given location of a Minecraft region file, like the ones that I had shown before. Then what I wrote was something that could deserialize that region from a file into one of these file format, like abstractions. And then I made basically two things. I made one application that can extract all the chunks from that region and then extract all the blocks from one of those chunks. We could extract all the blocks from the full region, but that is something in the realm of 38 million blocks, which for a CSV file is humongous. It would take, it's actually a lot of work. So visualizing it works better just chunk by chunk instead of a whole region. So what I'm doing here is I'm extracting all the chunks, and then for only one of the chunks, I am extracting all the blocks that then I am dumping into a CSV file. So if I run this, you can see that the console application actually did this very fast because a chunk is a fairly lightweight, relatively lightweight. And then I have this chunk file that I'm going to open, for example, with an Excel spreadsheet. And you can see that what I get is the XYZ coordinates of each block in order, and then the idea of what that block is made of. So in this case, it's bedrock, but if I start going up, they are ordered from the bottom, from the deep bottom, all the way to the top. So you can see that as I go up, things turn into deep slate, and it turns into duff, and now they turn into stone and more different kinds of stone. And then as I keep going up, it will probably turn into water, air, dirt. You see, we have now water, dirt, grass. We're approaching the surface, and then it's like a lot of air. Okay, and after that, it's just basically a lot of air. So this is great because now we have the information of each block in a very simple format that can be read by any program in the world. We just have XYZ coordinates and the block type. So with this, we can just visualize this in any platform that we can think of. So let me show you, for example, how I did that using Rhino and Grasshopper. So I am now in Rhino and I have this Grasshopper file open. And what I'm going to do is I'm going to read the CSV file that I saved to my computer into my Grasshopper file. And then you can see that what I get is an ordered list of strings with all the coordinates and the type separated by commas, right? And then what I can do is I can plug that in to a super simple deserializer. So basically what I have here is a C# script that takes that string and separates the commas and then takes the XYZ coordinates as integers, and then it takes the whole thing, the string, and if it's not air, because we don't want to visualize air, then it just outputs the type, right? And then what I'm doing is I'm filtering all those types by stone, gravel, andesite, whatever, and I'm giving each one of those a different color. So green for grass, brown for dirt, transparent blue for water, all that stuff. So as soon as I plug this in here, right, then you can see how it's taken quite some time, right? You can see how it took like something like 10 seconds because we have a lot of stuff, a lot of voxels, and each one of these voxels is being rendered as a cubic mesh. And as for right now, I'm not doing any optimizations of merging coplanar faces and removing them. So the geometry is actually fairly heavy. Those optimizations will probably come at some point, but I haven't implemented those yet. But you can see how now we have a full chunk from the surface all the way to the deep slate and bedrock. And you can see how cool, as we zoom in, you can see how we can see the caves all the way in depth. And this is iron, I believe. This is redstone. This is all deep slate. And oh, is that diamonds? Are those diamonds? Those are probably diamonds down there. Very deep all the way, right? And so we could just like take this now and bake it and do like a video like I showed before, right? We could also export multiple chunks and we could show them together. So I actually have a few files here of how to show different chunks together like I showed before. It's just that it's kind of heavy, again, because I'm still not doing optimization, and probably the heaviest part at this point is the visualization. That's why I'm actually so amazed by this project that is so fast. Living on a browser and including textures is just really, really responsive. It's kind of crazy. I really want to dig into this project sometime very soon. But one of the nice things that we can do with this is that because we basically have a full list of the coordinates of all the blocks and what they are, if we are looking for a specific kind of block, like for example diamonds or like iron ore or lapis or emeralds or whatever that is, we can go through all the blocks and we can just filter out the ones that are not what we're looking for, which is a very simple search operation. Let me show you how I implemented that. If we go back to the main code, I can cancel this part, the part where I extract the whole chunk, and I can show you how I have this one function that takes a collection of blocks and filters them by a particular ID. So if, for example, I only want to retrieve the blocks that are diamonds, I can just filter by diamond ore, and then I can dump those coordinates, the coordinates of those blocks, as a CSV file somewhere in my system. So for example, if I run this, now the application is parsing all the blocks, and because I'm doing it for the full region, remember this is a region is, I believe it's 32 by 32 chunks, and each chunk is like something like 40,000 blocks. So it's basically 38 million blocks potentially. And only from those, only 400 were found. So now I can go back to my system, whatever that is, and you can see that I have this diamonds list that has all the coordinates of just the diamonds. And if I were to now visualize that and say, well, what I want now is just the file r.diamonds. Okay, that's what I want to visualize. So if I plug that in here, you can see that I had a typo, so that.csv, and I still do have a typo. So what is the name of, no, so I have to close this before this can be read. And you can see that now I have, you can see all the diamonds on my full region all around the place. And I can combine the both if I wanted to, because it's just literally lists of blocks. So it takes a while, but you're going to see the one chunk here. You see the one tiny chunk, you see how big regions are? And then you can see the one chunk combined with all the diamonds that are available in the whole thing. However, this is not entirely true. You can see that the diamonds, if we were to see a frontal view, you can see that the diamonds are kind of only concentrated in a thin layer here. That's because with the latest updates, there's two kind of diamonds now. There's diamond ore and there's deep slate diamond ore, which is a different kind. So I can, for example, just say, well, can you give me deep slate diamond, or can you filter for both? And then just can you give me like a file with all of them, not just diamond ores, but both of them combined. And then if we parse that, how many diamonds we get now? 15,000, which is kind of very nice. And if we now change this to all of them, right? What is this going to look like? Let's see. Let's wait a few seconds till it renders. And boom, turns out that there were many more diamonds. It's just that many of them are actually hidden. And it's kind of interesting because if you do on front view, you can see how the density of where diamonds are increases the deeper you go, which is something that they changed very recently in the Minecraft updates with, especially when they introduced all the deep slate levels, you know, they move the frequency from diamonds from level 11, which is what they used to be, all the way down to the bottom. So this is very nice. It's also very helpful if you want to find diamonds. I have no ethical problems with using this to easierly to retrieve diamonds easier, especially if you have gone through the pain or the pleasure of writing the code to make this happen. It feels like you earned being able to hack through those diamonds. That's my very honest ethical opinion on this matter. You may subscribe it or not. All right. So I think this is where I wanted to leave this. I just wanted to show you this fun project that I did recently and how nerdy it felt to me. And I hope that at some point I actually get time to make a playlist and show you how I wrote all of this stuff. Would you actually be interested in watching that playlist and following up along? Let me know what you think in the comments on this video. All right. And in the meantime, if you found this to be cool, exciting, fun, or any of the above, maybe you want to consider liking this video, subscribing to the channel, turning on notifications to hear more from us, or joining our Discord server and joining the conversation that we have throughout the week offline. All right. Thank you very much, and see you on any other Minecraft related videos or computational design ones. Who knows? Thank you. Bye bye.